your modern cloud security companies. They write a bunch of code, and that bunch of code span up and create assets. It can be a software asset, it can be an application that is actually a composition of your build file, your website, your API endpoint, and your code that runs behind it. That get built inside container. Now, container is not just one entity, but it's a collection of things. It's an operating system, well, it's a VM, it's an operating system, and the application that runs on it. For simplicity of things, we're gonna just think about this in two ways. The application that gets built inside it and the operating system that support it. And then those things get shipped inside a bunch of other cloud assets. Now, unfortunately, the people that maintain this side of the world doesn't talk to the people that maintain that side of the world. And that's the challenge that we have. So when you ask, hey, is my container secure? I don't know. I don't know what software runs in it. Who owns it? I don't know. I own this part of the world, but for them, it's basically a dark area. And then if you ask these teams, is your application secure? Yeah, I've wrote my code, I run my scan, so maybe this part is secure. But is it running in a secure system? Is it running even? The simple question is your application running? Is your repo running? Or what part of the repo is running? That's a very complicated question to ask a developer. So those people try to patch this system. They don't know who owns it, so they leave it. These folks can't report to anything, so the CISO or the security person asks them, can you please fix the vulnerability? I don't know which one to prioritize. So to solve the world, we need to solve this in two different ways. Well, you need four different elements to fix this problem. We need to know the states of a specific thing, so who has generated something and where that something has manifested. It's a concept called Lineage. The container actually change in terms of states. Attribution, who owns what piece of the infrastructure or code, and hence we can attribute the vulnerabilities that we found in these pieces to them, because those are the only people that can solve it. And it's pointless to attribute the container stuff to the operational people, or at least the software part needs to be attributed to the developers, because they are the only people that can actually go and touch your build file, upgrade the library, and so on. But knowing who does what where is the tricky part. But knowing which piece of software gets built in which container and get one where, that's one of the fundamental concepts of reachability analysis. So is your particular software or your particular library built in a container that is running and is interfaced to the web? So is that particular library reachable? Built inside something, running in runtime. Those are all similar concepts. You're gonna hear them a lot in the industry. There is a lot of noise around this because it seems dark magic, but it's not. It's actually good engineering. Now, there is a lot of companies that are gonna go out there and say, hey, we have the magic formula about reachability analysis. There isn't a magic formula, it's just good engineering. And then the last piece is traceability. So knowing which application runs in which container and then which container runs where. So those are the four concepts: attribution, lineage, code to cloud, reachability, that you need to know or you need to build. And these are the things that we focus in Phoenix to build a complete picture of risk. And to say, focus on this, don't focus on this.